In this video, I'm going to be explaining you all the spherical lenses as well as its components. Actually, it is biconcave and biconvex lenses, and we are starting right now. Hey, this is Advaith. Welcome to another video. If this is your first time here and you want to learn how to build your memory, build your brain by uncovering fascinating facts and clear academic concepts, start now by
subscribing and clicking the bell so that you don't miss anything.
So we are going to be doing this on the big whiteboard which we have. But before I go on, I'm assuming that you know the parts of spherical mirrors very well, because I'm not going to be going in detail of what is aperture, for example. Now, if you want that thing to be in detail, you want that explanation to be in detail, I have made a video on the parts of spherical mirrors. I'll leave a link up here in the cards right now. You have to go and check that first if you want it in detail, and you can come over here after watching that video. Now let's jump over to the big whiteboard. So the major components that I'm going to be explaining today about the lenses are centers of curvature. It's in plural form, I'll tell you why. Radii of curvature, principal or optical axis, optical center, as well as the aperture. We are going to understand these five in terms of biconcave as well as biconvex lenses. So now we will understand this in a moment. Before I go on with all those center of curvature and all those stuff, I'll be giving a short definition on what are lenses. So lenses are simply glass pieces which are transparent, but it should have at least one curved area or a curved surface. So a cuboidal glass slab is not a lens, but if it's a square or a cuboid on one side and it is curved on one side, then this will form a lens. So a lens should have at least one curved surface. Now this is the biconvex, because both the sides are convex, that's why bi means two, and this is biconcave, because both the sides are concave, and bi means two, no matter what it is, like binary fission, biconcave, and all the stuff. Now we will understand centers of curvature. Now, why I am referring to it as centers? Why not only one? Because in the spherical mirrors there was only one center of curvature, and similarly I also told that it is not radius, it is radii. That means it's in the plural form. Why? Because in these two lenses, if you observe, there are two curved surfaces. One is this one is this one. In this case, this and this. So in the mirrors, we used to complete the whole sphere of which the mirror was a part of. If you remember the very first session which I took. So if we complete this from this side, this forms one sphere, this boundary. Now this is also a curved surface, so this will also be another sphere. So, or an imaginary circle. So now obviously we have two spheres or circles. These two circles will have their own centers. Let's assume this is the center, center 1. This is center 2. Now if we observe in one single piece of lens, in case of this biconvex lens, we obtain two centers, and we already know that since the sphere is no longer a part of the lens, we cannot call it the center of sphere but center of curvature. So even this is center of curvature and this is also center of curvature. So there are two centers. That is why we refer to as centers of curvature in case of a lens. Because there are two curved surfaces, that means we can complete two circles because of the curved surfaces of the lens. Now we'll understand in the case of biconcave. Again, there are two spherical surfaces. One is this one and the other is this one. Now if we complete this circle and this, so we now again obtain two circles. Two circles will have centers C1, C2. So again there are two centers, no matter what the lenses are. Again it is centers of curvature. That is why we refer to the lens as centers and not the center. So now obviously we have two centers. we have two circles, two centers. So how many radiuses will be there, or radii will be there? Obviously two, or you can, actually it's infinite. I mean, what I mean to say is two individual ones. So again, in this one, it is this, we can draw this, we can draw this, we can draw anywhere. So there are two different types of radii, that's what I should say. So that is why we refer to as radii of curvature and not radius. It's in the plural form. So the centers, since there are two centers, we have two radii, because two centers due to the two circles and the two refracting surfaces. So now we understood centers and radii of curvature. Now we will understand aperture and all those stuff in a moment. Now we'll understand aperture, optical center, and principal or optical axis. So now we can see that there is biconvex and biconcave lens. So what did we study about aperture in the mirrors? We studied that aperture is the total reflecting surface in the form of 3D, but actually in that aperture we call it as the diameter between so and so and so and so, this point and this point, because we can only represent the 2D form. Otherwise, in a 3D figure, aperture is the reflecting surface area. So now, since we know it is the total reflecting surface area of the mirror, in case of the mirrors, here it is just the total refracting surface. That means the whole refracting surface of the lens is known as aperture. So this, everything is known as aperture. Aperture is total refracting in the case of these two lenses. Refracting surface areas. This is aperture. Now what did we study about pole? Pole is the geometrical center of this aperture. That means it is somewhere in the middle. This is the middlemost point of the aperture. Similarly, we cannot call this pole. We won't call this as a pole. Instead, we call this optical centers. So, center of aperture is known as optical center, not pole. Pole in the case of mirrors, optical center in the case of lenses. Now we understood the center of aperture, which is optical center. Now we'll understand principal axis. Again, the same concept. What was principal axis there? An imaginary line which is joining the center of curvature as well as the pole in the case of the mirror. Now we have two centers of curvature. If we draw an imaginary line joining both the centers of curvature as well as the optical center O, this line is known as optical axis or principal axis. Similarly, in this again, assuming this is one center of curvature, this is another, this is the optical center. Again, this is known as the principal axis. So it was very similar to that of the mirrors. If you understood the mirrors parts, then this would be very easy. And that is why I first told you to watch that video first. So now we understood everything. And if you want to go a bit in detail about all this stuff, the first video which I made on the parts of mirrors is the video for you. You should go and check that. I have already linked in the cards that little eye icon over here, somewhere over here. You have to go and check that out. Or else you have the whole live playlist linked in the comments below. I have pinned that comment so that it will stay on the top and you can read it easily. As you may know, I have created a Telegram link for all my subscribers, a Telegram group, the link to which is in the description right now. You can join it anytime. If you're a subscriber, you are most welcome to join. And if you want to build your memory, brain, or clear academic concepts, start now by subscribing and clicking the bell so that you don't miss anything. I have linked you some videos so that you don't waste time searching for them, so that time is precious for you, so that you can save your time. Thank you so much for watching. I'll see you next time.